For most of the 20th century, our map of the solar system was a closed set. We tracked the rocky inner worlds, the gas giants, and finally, Pluto, the solitary, icy outpost at the edge of the known map. Clyde Tombaugh's discovery of a faint, moving speck in 1930 seemed to complete that map. Astronomers analyzing survey data from the Palomar Observatory announced they had found a massive anomaly deep in the outer solar system. They nicknamed the object Xena. It was a highly reflective, frozen world, so bright it acted like a cosmic mirror in the freezing dark of the scattered disk. Unlike anything in the planetary census, the 8 major planets stay on a relatively flat plane, while Xena's path slices through at a 44-degree angle. Because astronomers historically searched only that flat plane, this massive object evaded detection for decades. Finding a world this large where it shouldn't be revealed that our existing maps of the solar system were deeply flawed. To determine the new world's mass, astronomers tracked its tiny moon, dysnomia. By measuring the moon's orbital period and distance, they applied the laws of gravity to calculate Xena's weight. The definitive result? Xena was 27% more massive than Pluto. Headlines across the globe immediately announced the discovery of the 10th planet. For the public, the solar system had simply grown by 1. But for scientists, this created a crisis of classification. Recognizing this heavy new object as a planet meant astronomers would likely have to grant that same status to dozens of other large icy bodies appearing in the Kuiper Belt. This massive discovery collapsed the classification system astronomers had used to define the solar system since the early 20th century. In August 2006, the International Astronomical Union gathered in Prague to address the chaos. The members had to confront an awkward fact. The word planet had never been given a formal scientific definition. The geophysical camp argued for a definition based on shape. If an object's gravity crushes it into a round sphere, hydrostatic equilibrium, it should be a planet. This rule would instantly expand the solar system, adding Pluto, the 10th object, Ceres, and dozens of small worlds. The dynamical camp disagreed. They contended that a true planet must be more than just round. It must be a gravitational master that clears its orbital path of other debris. The debate forced a choice between defining a planet by its physical state or by its gravitational impact on its surroundings. Xena's environment in the scattered disk reveals the problem. It exists in a shared field of icy planetesimals and debris, far beyond Neptune's influence. This chart compares a planet's mass to the material in its orbit. Earth and Jupiter account for over 99% of their zones. Pluto and Xena represent a tiny fraction. Sharing regions with thousands of other objects, neither has cleared its neighborhood. Eris redefined the outer solar system as a massive, shared belt of icy dwarfs, overturning the image of a neat row of isolated planets. On August 24, 2006, the astronomers in Prague cast their votes to finally settle the matter. They established a new 3-part definition. A planet must orbit the sun, it must be round, and it must clear its neighborhood. Pluto and the heavy 10th object failed the 3rd test. They were stripped of their planetary status and placed into a new category, dwarf planets. With the category decided, the IAU gave the new world its official name, Eris, the Greek goddess of discord and strife. Eris earned its name by forcing a reorganization of astronomical science, requiring textbooks to be updated across the world. The discovery of Eris proved that science is a living process, where our definitions must shift to accommodate new evidence. Eris didn't just take away a planet, it gave us a more accurate map of the universe.